Okay. So the first thing is a really nice chart that tells you for means how you do two-sample testing for independent samples. So it's a nice little flow chart. First thing you got to know, are both population standard deviation known? If the answer is yes, are they both normal, or is the sample size at least 30? If the answer is yes, you're using the z-test. That's A16, A17, that z-chart that you have. And this is section 8.1 that we just did. If both populations are normal, or are both sample sizes at least 30. So let's say we don't know the population standard deviations. This is the path you're going to be taking for your projects, because we do not know the population standard deviation of anything that you're going to be investigating. And you have to have both sample sizes at least 30, or the population's normal. If the answer is no, you can't do anything. Here is where you stop. If the population variances are equal, that means both, you may not know the population standard deviations, but are they varying approximately the same way? If the answer is yes, you use this formula, and if the answer is no, you use that formula. There's two different formulas that you have to use. Okay, so no matter what, whether, and so this is 8.2 and this is 8.2 here. Two different ways to do questions for 8.2. No matter what, with the 8.2 formula, you're using this one right here. Remember, x bar 1 minus x bar 2 is just your two sample means. What is mu 1 minus mu 2? 0, and it's always 0. So cross that out and write 0. But remember that on the AP test, when they give you formulas, they will say mu 1 minus mu 2, which is not a thing right now. And then down here, this changes. And it's either going to be that one or that one. And it's a bunch of stuff. If the variants are equal, there's like a pooled estimate of standard deviation, where you would have to, on the bottom, have this is the standard error right here. That's what that symbol means. So on the top will just be one thing minus one thing. You don't have to write minus 0. And on the bottom, you're going to take, so this is like the bottom here. You're going to take this standard error, this huge formula, times this huge formula. So we're actually going to write the big formula on the side and decode it together so that you can reference it for the two different things. Okay, so we're talking about if the variances are equal or the variances are not equal. Everything else is the same about this hypothesis testing. The same process for null and alternative as it was for 8.1. It's just that formula is going to change with your t-score. So if the variances are equal, it's this horrific formula that looks something like this. I want to zoom in far enough, but at the same time I want you to see where I'm getting information. So the top is x bar 1 minus x bar 2. The bottom is going to be a huge mess. The bottom is going to be this standard error, which is this thing, times this thing. So you take this big square root times another square root. And the top one is n1 minus 1 in parentheses, s squared sub 1 plus n sub 2 minus 1. I'm just copying. . Do you guys see where I'm getting this formula? Right here? Because that's the standard error. And then that's times 1 over n sub 1 plus 1 over n sub 2. Now, the nice news about this horrible, horrible formula is that you can do it in your calculator. And yeah, there actually might be like one problem in multiple choice or something where they ask you about the formula, but I mean, one problem out of 40, and unlikely at that. They definitely want you to be able to use the formula. So we're gonna try the formula like at least once, and then on the homework, we're going to use our calculators to figure it out for us. If variances are not equal, you use this formula. Same thing on the top, x bar 1 minus x bar 2 over, and on the bottom is just something a little easier, s squared sub 1 divided by n1 plus s sub squared 2 divided by n sub 2. Also, your degree of freedoms are different for each one. The degree of freedom, if the variances are equal, is n sub 1 plus n sub 2 minus 2. And if the variances are not equal, the degree of freedom is whichever one is smaller. Either n sub 1 minus 1 or n sub 2 minus 1. All right, these are a little hard to look at. Complicated to understand. Okay. So we're gonna try this now. There's a T-chart here which gives you steps. But we're gonna try it together. Which one do you wanna do? The gross one is gonna be the population